Good morning, everyone. My name is P. Mahendra. I am currently in my fourth year of BTech at PBR WITS. Today, I am going to discuss about the things we learned in internship and a brief explanation about home automation project. First of all, take a look on the contents that we are going to discuss. C and C++ programming. What is IoT? Example for IoT. IoT architecture, embedded system, and what are the tools we use during this project. Arduino IDE, PiximLab, Blink application, and at the end we are going to see the working of project. First, C programming. C programming is considered as the base for other programming languages. That is why it is known as the mother language. C programming language was developed in 1972 by Dennis Ritchie at Bell Laboratories of American Telephone and Telegraph, located in the USA, where it is used. Software development, system software development, embedded software development, OS kernel development, and film system development. It is a general purpose language. We have 32 keywords in C programming. And some of the topics we covered during this project is first one is data types. A data type is a attribute associated with a piece of data that tells a computer system how to interpret its value. A data type is the type of data a variable can hold. There are three types of data types: primitive data types, user defined data types, derived data types. Second one is conditional statements. The conditional statements, also known as decision control structures or decision making statements, they are generally used to evaluate one or more conditions and make the decision whether to execute a set of statements or not. And some of the examples of conditional statements are if else, yesterday, if else later, switch. Next, operators. Operators in C language are symbols that represent operation to be performed on one or more operands. They are the basic components of the C programming. There are three types of operators: unary operators, binary operators, ternary operators. Next one is arrays. Array, array in C can be defined as method of clubbing multiple entities of similar type into a larger group. Arrays are lists of related values. It's a type of data structures. Functions. A function is a block of code which only runs when it is used. Functions are used to program certain actions. Next one is pointers. Pointers are one of the large component of the C programming language. A pointer can be used to store the memory address of other variables, functions, even other pointers. It is a derived data type generally used to store the address of the C variable. Strings. A string in C programming is a sequence of characters terminated with or null character. Preprocessors. The C preprocessor is a macroprocessor that is used automatically by the C compiler to transfer your program before actual compilation. To initialize a process of preprocessor command, it's mandated to define with hash symbol. Storage class. C storage classes are used to describe the features of a variable slash functions. These features basically include the scope, visibility, and the lifetime, which help us to trace. Next, C programming, C++ programming. The C++ was invented by Bajorny Stroustrup in 1979 at Bell Laboratories. He initially called the new language as C with classes. However, in 1983, The name was changed to C++. C++ is a statically typed, compiled, general-purpose, case-sensitive programming language that supports procedural, object-oriented, and generic programming. Adds many features to the C languages, and it perhaps best thought of as superset of C. It is a object-oriented programming language. What are the principles of OOPS? First one is encapsulation, abstraction, inheritance, polymorphism, modularity, dynamic binding. First one is encapsulation. Encapsulation. It involves bundling data attributes and methods that operate on the data into a single unit or class. This helps in hiding the internal state of the object from the outside world. Next one is abstraction. It involves representing essential features without including background details. It allows a programmer to focus on interactions at higher level without worrying about implementation specifies. Inheritance. It allows a new class to inherit properties and behavior from an existing class. This promotes code reusability and establishes a relationship between parent and child classes. Next one is polymorphism. It allows objects to be treated as instance of their parent class with the ability to override method and provide different behavior for the same method name depending upon the object class. Next one is modularity dynamic binding. It refers to the process of linking a procedural call to the specific method at runtime rather than at compile time. This is closely related to polymorphism. And the next, class and object creation. A class is used to specify the form of an object. An object is a real world entity that an entity which has data and functionality. Constructor and destructors. A constructor is a member function with the same name as that of class. Destructors is used to deallocate the memory which where when an object is destroyed. Next, IoT, Internet of Things. First, what is IoT? The network of physical objects that contain embedded technology to communicate and interact with the internal states or the external environment. It collects the information from lot of devices. Here, devices are nothing but embedded devices, embedded systems, merging perspective between the devices, systems, and humans to build a better understanding of the world around us. Next, IoT. It is the example for IoT, voice assistance. Next, IoT architecture. IoT architecture is classified into three parts. First one is device connectivity. Second one is data processing and analytics. Next, third one is presentation. In the first part, device connectivity. Here, devices are not devices are embedded devices. Some are capable to connect with the internet. Some are capable to connect with the cloud, but some are not capable to connect with the cloud. For that devices, we are using Ethernet sheet for connecting with the cloud. And next one is data processing and analytics. Data processing transforms raw data into something usable. It involves a series of actions and steps turn data into insights. Knowledge or information that can be used for decision making, analysis, or other purposes. Data analytics. It is the analysis of data generated from connected devices. It often the critical technology for interpreting the meaning of data patterns. Last one is presentation. presentation and business connectivity. Next, embedded system. What is embedded system? An embedded system is combination of hardware and software which is intended to do a specific task can be called as embedded system. Main components of embedded system. First one is sensor. A sensor is a device which converts the environmental changes into an electrical signal, and the output of sensor is input for A to D converter. A to D converter converts the analog signal into digital signal, and the CPU, central processing unit. In embedded system, it is heart of the embedded system. It controls the system basic functions. Next, D to A converter, it converts the digital signal into analog signal. Next one is actuators. This actuators converts the electrical signal into physical action. And memory. Memory in embedded system is a physical storage embedded device used to store two type two data types. The embedded system retrieves data from memory, processes and output data saved in memory. Next, the tools were used during this project. Arduino IDE, PiximLab, Blink application. First one, Arduino IDE. The Arduino IDE is the essential tool for unlocking the power of Arduino boards, allowing you to write, compile, and upload code that brings you embedded projects to life. PiximLab. PiximLab is a real-time emulator of development boards with MPLabX debugger integration. Blink application. Blink is a platform for development of smartphone applications that works with a wide range of microcontrollers. It is free of cost. Next, our project. Home automation using Arduino and Blink application. This is our project. The functional requirements for our project: LDR sensor, temperature sensor, serial tank, LED, LCD. First, LDR. LDR stands for light dependent resistor. It functions as a sensor that changes resistance based on light intensity. The LDR sensor works in the automated lighting system, effectively adjust the brightness based upon the ambient light conditions. Temperature sensor. A temperature sensor is a device, typically a thermocouple or resistant temperature detector, that provides the temperature measurement in a readable form through a electrical signal. Next, serial tank. The serial remote tank is a tank simulator controlled by serial communication protocol. Tank has several sensors and actuators that can be read and controlled using communication protocol. LED. LED stands for light emitting diode. It is a widely used standard source of light in electrical equipment. It has a wide range of applications ranging from your mobile phone range to large advertising billboards. LCD stands for liquid crystal display. There are many of them out there and can usually tell them by a 16-pin interface. The interface consists of following pins: register select, read and write pin, enable pin, 8 data lines. And in this project, we mainly focused on home applications. Some of them are given below are garden light control, temperature control system, water tank inlet and outlet valve. First, garden light control. By using this, we can control our garden lights based on brightness of sunlight. Here we are using LDR sensor. Its resistance of LDR sensor varied depending upon the light. Based upon that LDR sensor, light brightness will increase and decrease. This is the output picture of golden light control. And next one is temperature control system. The temperature control system consists of heating resistor, an LM35 temperature sensor, and a cooler working. First, it reads the temperature from the temperature sensor LM35 and display it onto the CLCD. It works in different ways. Some of them are temperature control system, cooler control system, heater control system, and threshold temperature control. Temperature control system. In this system, we only measure the temperature. First, we read temperature from temperature sensor LM35 and display it on gate widget on CLCD. Cooler control system. In this system, we detect the changes in logic level based upon the button widget and presented in Blink application. If the widget button widget is at logic high, turn on the cooler. If the button widget is at logic low, turn off the cooler. Heater control system. In this system also we detect the changes in logic level based upon the button widget presented in Blink application. If the button widget is high, turn on the heater. If the button widget is set low, turn off the heater. Next, this is the output of temperature control system. Serial tank. By using this application, we can control the volume of water and we can able to know the volume of the water in the tank. First, displays the volume of water in the tank. First, it reads the volume of the water on gauge widget and then displayed onto the CLCD. Inlet valve control. It detects the change in logic level. If the widget button is at high, turn on the inlet valve. If the button widget is at logic low, turn off the inlet valve. Valve outlet valve control. It detects the change in logic level and if the button widget is high, turn on the outlet valve. If the button widget is at low, turn off the outlet valve. Control the volume of water in the tank. It reads the volume of water in the tank by sending commands through serial communication. This is the picture of serial tank. This is the overall project picture. Now we are going to see the project demo. Let me here. Let me connect my serial tank. Let me explain what are the things we need to control. First, we need to control garden light. Here we have LDR and LED. When we are varying this resistance, when we are varying the resistance, LED brightness should vary. Here we are simulating the brightness. Less, less the brightness, more the light will glow. More the sunlight, less the light will glow. This is our first requirement. Our next requirement is temperature control system. Here temperature is need to control through heater and cooler. We can see my you can see my mobile screen. Through these buttons, I'm switching on heater and cooler. When I am turning on the cooler button, you can see the cooler is switching on and the same thing is reflected on the CLCD screen. And when I am turning it off, cooler is switching off and CLCD is representing cooler off. Next, heater. When I am switching on the heater pin here, the temperature is rising. And you can also observe the temperature in your mobile through gauge. And CLCD is representing the temperature and the status of heater. And now, as per our requirement, when the temperature of the room is more than 35, automatically heater is off. You can see the heater is off and the temperature is decreasing. This is our requirement. Here we are not, here I am not turning off the heater pin. It's automatically turning off when the temperature crossing 35 degrees Celsius. And our next requirement is serial tank. Serial tank. Both inlet and outlet wall were controlling through inlet pin and outlet pin. When we turning on the inlet pin, let me on the inlet pin, the water will start filling in the tank. When I am turning off, you can see although also the status of the tank and how much volume of water in the tank. And when I am turning it off, it's showing inflow off. And when I am turning on the outlet pin, the water is going out. You can see the water is going in. 1 minute, 1 minute. Let me off. And first, I'm turning on the outlet pin. The water is going out. What wrong here? Give me 1 minute. I'm both switching up the both pins. When I am turning on the inlet pin, the water is filling. As per our requirement, when it's reach maximum volume, means 3000 liters, the automatically the inlet is off. And when I am switching on the outlet pin, the water is going out. As per our requirement, when the volume of the water less than 2000, the inlet pin will automatically on. You can see I'm not switching on any of the inlet pin here. It's automatically getting on. This is our project. Conclusion. In this project, we mainly focus on the home auto application by using Blink app, Blink IoT application and Pixim Lab Simulator, simulated home automation where LED temperature system serial tank resembles light, heater and cooler and water tank in real time. Finally, I would like to extend my heartfelt thanks to Emertxe for this incredible opportunity. And I also want to express my gratitude to Jayalakshmi Madam for this continuous guidance and support throughout my internship. Thank you.